Hello, today we'll be talking about the decision tree overfitting problem and also about early stopping and pruning. Now, what are the reasons for overfitting? Some of the reasons are the presence of noise in the data, such as tuples with identical attribute value pairs but different labels, or there could be errors in data acquisition process leading to incorrect attribute values. There could be error in labeling the instances, or the decision tree may try to learn irrelevant attributes, like attributes which are irrelevant to the current decision or task, and this could result in overfitting. Further, too little data almost always results in overfitting. Now, we see this the graph where we are plotting the max depth and the tree depth and the classification error. We can see that the train error is coming down or reducing up to a large by a large quantity as the tree depth increases. However, the true error or the error on the validation set or the true set in real application, it increases. So we would want to stop our tree at this point, at this error point. So what do? We can, using the validation set, we can find out the max depth. Okay, that this is the depth up to which we would allow the tree to grow. So there are two ways of doing reducing the overfitting or restricting the overfitting. Is one is early stopping, that you stop the learning algorithm before the tree becomes complex, or you simplify the tree after the learning algorithm terminates. Now, the early stopping criteria could be by limiting tree depth, or you do not choose splits if there is no sufficient increase in validation accuracy. And further, do not split an intermediate node with too few data points. You can put a threshold as to the number of samples in a node if it is to be split further. Now we go through some examples. Consider this scenario where you have reached point where F3 feature is being considered for the split case, and at this point you have, say, 4 positive and 2 negative samples, and when you split on F3, F3 being 1 or F3 being 0, you get, say, y's or positives, 2 positives, and we have 1 negatives. We could also call it by y and n, 4 y's and 2 n's. And here also we have 2 y's and 1 n. Now, should we prune this subtree at this point and replace it with a leaf where we are having 4y and 2n data points and make it predicted as a yes class or a positive class based on majority voting? Should we do that? It seems yes, because the prediction accuracy or the percentage confidence in predicting positive is 66% at this point, and even after splitting on two branches we have the same prediction percentage. The confidence in prediction remains 66% even here. So we could we could prune this subtree. So prune this subtree, and we could replace it by a leaf node. So we replace the subtree and make a leaf node which is predicted as Y class by majority voting. let us consider one more example, in which case we have at this point, similarly, falling down the branch, we come to F3, splitting by F3, and we have the 3y and 1 negative, and you split on y F3 as 1 and 0, and you get 0 samples along one branch and all the samples along the other branch. This also is a sure case of pruning, as we can very well see, and replaced by a leaf node with 3y and 1n to be predicted by majority voting. So, this also should be pruned. Okay, so these two examples illustrate to some extent the scenarios where pruning would be a good idea. Further, we could also have a method of scoring trees where we would want to balance how well the tree fits the data and a measure of complexity of the tree. Simple measure of complexity we could take as number of leaf nodes. We'll very shortly come back with an example where this is incorporated. Thank you. Thanks for watching.